Well, thanks first of all to Nick and Hannes for having me here. Thanks to the Vodafone Institute. And I'm having the pleasure of giving you a very short argumentation of why I think intelligence needs a body. And I'm trying to convince you in these short, up to 10 minutes, whether the next generation of artificial intelligence is actually the one that is able to interact with all of you guys. So I think an argument being done here is very easy, because if I remember 2016, artificial intelligence in cognition, all of you know Google DeepMind beating, in terms of the AlphaGo system, Lee Sedol, who has been the grandmaster in Go. And I think this was a very big shock all over the globe. But interestingly, there is one question. If on the right side there's Lee Sedol, the grandmaster in Go, then who the hell is the person on the left side? So all of you should actually ask yourself this question. So there seems to be a kind of contradiction. The machine itself has been calculating the moves, but the human has to see the stones, grasp them, and move them accordingly. And this reminded me almost 20 years before to my time at high school, when Google was IBM, Lee Sedol was Garry Kasparov, the famous Russian chess master, grandmaster back then, and the same question could arise there. Who the hell is the person on the right side? So we have been shocked by the cognitive abilities of machines being able to beat us in games that we have been developing and being the originator as humans. But same thing here, there is a person, a human, just because he's a human, he's able to see the chess figures, grasp them according to the plan of the artificial intelligence, that is a chess machine in some sense, and then places them accordingly and correctly. And when it comes to kind of sensory motor skills, so grasping, manipulation, interacting with the world, then where are we in comparison to this 4-year-old child, being my daughter, after I told her, if you could clean up, no, you have to clean up the living room if you're not able to open the door within less than 10 trials. So I'm doing all kinds of experiments with my children, 3 of them, and I can really see how intelligence kind of evolves over the years to come. And if we compare this to the next generation of artificial intelligence, being intelligent robotics in the year 2015, I think it's kind of clear we are having a serious problem here. So even the most advanced systems back then at the DARPA Robotics Challenge in 2015 were not able, despite millions of investment into these kind of artificial systems that are able to interact in principle with the world. However, the 4-year-old child could not be beaten, in contrast to the cognitive abilities, meaning Lee Sedol or Garry Kasparov. So there seems to be a gap. And what is the argumentation that we could, or what is the rational argument why this is the case? And there is actually a very intuitive kind of analogy, if we want to draw it, and I'm a very kind of big fan of very simple analogies. The concepts of mobility or manipulation have been separated by billions of years of evolution, right? So in some essence, a single cell organism can travel from A to B, can go from A to B, like an autonomous car will be at some point. So this has been there for many years. We all have been doing the microscopy in the 10th grade of high school. But if it comes to the manipulation of the world, grasping the environment, manipulating it, and developing tools like the Stonehenge and all the other Stonewedge and all the other things we have been developing, then it actually took primates to be able to do that. So there is a fundamental difference between data, information, and skills, being mobility or even manipulation. So fundamentally, they are very different and complex. So in some sense, if we are kind of coming back to one of the most famous artificial intelligences in the history of science fiction movies and series, then I'm sure all of you know Data, the very famous humanoid in Star Trek, despite I'm not a Trekkie myself, but I think all of you are aware of that Data at some point was even able to have some sense of humor. So we could even argue that Data was kind of promised over many decades, but all we got was data, in a sense. So I think there still seems to be a fundamental gap in what we actually would believe is artificial intelligence over the last 30, 40 years, but what the discussion is as of today. So we're kind of having a discussion that only and solely is around the data analysis and machine learning and what can we do with all these predictive analytics and so on and so forth. But what is the next step that we would take, and what is really the future of artificial intelligence? So I think it's kind of very clear, at least to scientists coming from the field, that the actual challenge of AI is AI-enabled robotics. So really systems in the real world that have a body, that are able to interact with all of us in our world, because I think this is really the thing that is missing. And this is actually also an analogy with all the science fiction stories that you all know of. Being, for example, the iRobot movie in 2004, which has been basically an adaptation of one of the famous stories of Isaac Asimov, the famous science fiction writer, who also introduced the fundamental laws of robotics, and also AI being the Spielberg movie that was originated actually from Stanley Kubrick, the mastermind behind 2001. So if we come back to that, then I guess we should ask the question, if this is really the end game of artificial intelligence, being possibly connected AI robots, then where are all these robots? And then obviously we come into the discussion that we already had a couple of times during the day, that all these systems will in some sense steal our jobs, right? So this is the fundamental statement that we see every day, and then we should actually ask ourselves, where are all these robots? Since I think most of you are still human, I think it's kind of interesting that basically 99% of the robots are behind fences. This is where they are. This is where they belong, right? And it's only 300,000 a year that are being sold in industrial manufacturing, and they mainly do spot welding and painting, the dull, dirty, and dangerous jobs for humans. But what is also interesting is that these devices are barely what we would actually call an artificial intelligence. I would even argue they are not intelligent at all. They're basically doing repetitive tasks, being position controlled, don't have the skills to do other things than the things they were told to, and they do it for 10, 15 years. So this had to be changed, and this obviously is also something where we really kind of have an advantage, I would say, in Europe, because we are kind of in the industrial sector very strong, and this is really where engineering meets computer science, exactly the discussion we saw in the panel before, Airbus being one of the examples, how you can really build on cutting-edge engineering and really bring together systems that are then kind of being able to do new things you have not seen before. So what it was kind of our vision over many decades, in fact 25 years in total, and me being part of that about 17 years, has been to really bridge the gap between humans and machines, tearing down the fences and really having a future of human and machine, not human or machine. And this has been a vision that we put together around 2009, really putting together the first sensitive and teachable robot tool, meaning that we don't want to have robot systems as in the past that basically substitute humans, but really are a tool that make it possible for us to be, again, economic in terms of manufacturing and other tasks that might be of interest. So having a system that supports human during work and is able to create new jobs in Europe, create new markets and economies, and also reduce inhumane work. And this was brought together even into a startup, and you can see in the other the system really performing certain tasks, where we brought together a startup called Franke Emica that is now being based in Munich and has really brought this vision into realization. And what is the core of this? This basically is the first robot system that really has a sense of touch, that does not need safety cages, and that can also be programmed by everyday people, being already trained workers or even laymen in order to use these tools. And where are we in Europe? Obviously, we always look to the other side of the ocean, and it's always nice to see that the things we're doing are being appreciated. So it has been on the Time magazine cover recently of the best invention in 2018, a German robot in some sense, but at the same time we should be humble still, because in the middle we see a driving helmet for bicycles being among these inventions. So, and what does this mean? Robots that we can take by the hand. They have a sense of touch. We can grab them, we can teach them like a child. They're extremely safe for interaction. They have a sense of touch. They have reflex systems similar to humans. So these are things that have only been science fiction literature, but now they have actually come to reality. And how does it come to the artificial intelligence with the body? So I just showed you my little daughter in the first and second trial when she was not successful, but after about 10 trials, she was actually able to insert the key into the hole. And where are we in terms of robotic systems? Are they able to do it? Yes, we can do it in terms of programming. So a highly skilled worker, highly skilled robot programmer could program these new devices with a sense of touch to do exactly what I was telling you, but we even extended this towards learning, meaning artificial intelligence that has a body, that is aware of that it is attached to a body, and therefore only runs on very small PCs, not needing large-scale machine learning clusters, but actually highly efficient systems that make this robot able to be learning things like little children are doing this typically. So, and the interesting thing is that not only the robot was able to automatically learn to insert the peg into the hole, but bridge and give this knowledge to the left robot that then for the first time, despite it has never been programmed, is able to insert the key into the hole like a 4-year-old children that needs 4 years to actually be able to develop such skills, such dexterity. And then actually optimize these skills to really kind of become an artist in exactly this task. Obviously, the next question, and basically being the fact that it would be true artificial intelligence, is can we take this knowledge and use it to solve a problem that the robot has never seen before. And this is exactly what we see here. So another key, another hole with the same skill that was learned within a couple of minutes, first time ever, and the robot is able to use this new key, put it into the new hole, open it, despite it has never been programmed to be doing that. And the next thing that really comes and bridges the gap between artificial intelligence, robotics to become AI robots is really the connection of multiple systems, possibly hundreds and thousands of these systems. This is something we showed last year on CeBIT together with Vodafone, the first robots that are being connected via 5G networks, and therefore having one human being able to operate multiple of these robots, and therefore kind of multiplying the skills of the humans and democratizing skills in a certain extent. The final thing I wanted to bring to you is kind of what can we do now in the future? Telemedicine was something that Chancellor Merkel was mentioning, and this will be one of the visions that we are driving forward over the next years. Really having the ability for medical doctors to be at remote locations instantaneously, which obviously not only needs the networks of the future, but also the sensory equipped avatars that you can really directly connect to, therefore bring the medical doctor into this kind of avatar within no time and be able to act in this particular incident where there was identified, for example, certain medical condition via IoT sensors that could be woven into the clothing of the future, and then being not only able to talk and hear what is going on, so audio, visual communication, but actually even be able to act in this remote environment via these safe and sensitive avatars. So you can basically grasp the ultrasonic device, hold it to the breast of this patient, be able to detect what's going on there, use AI algorithms to enhance the recommendation system for the medical doctor at site, and therefore be a support in saving lives instantaneously. Thank you very much.
Thank you. Thank you, Sami. Thank you so much. It's fascinating to hear about and think about what that new era or next era could look like. So from thinking about the next stage of AI and robotics, we're going to focus next on the next stage of connectivity. Please welcome Dr. Hannes Amtsreiter, CEO of Vodafone Germany.
Good afternoon, everybody. Well, intelligence not only needs a body, it also needs infrastructure. And I would like to share the visions we have about infrastructure, about how we would like to move forward and what we can expect. And also show you what we are thinking about services, what we are doing already, how we are deploying 5G, and the kind of thinking and the kind of future we think about. And of course, Europe plays a role. We heard that many, many times before. Europe is the most industrialized region in the world. And the question is, how do we make steps into the future to really see prosperity? And we believe infrastructure plays a vital role in that one. Coming to cars, there are recently many discussions about cars. It's about security, security threat. That's not our discussion. We want to have more security for people. That's why we're using technology. And the way we're using technology, and it might sound simple, but it's not really simple. So if you're driving with a car, of course you can see what's going on the street. If you're using some very advanced LiDAR radars, so using cameras, you can see what's going on in front of you. But with technology and network, you can see what's going on around the corner. And then you can maybe and hopefully avoid a crash. So I mean, that's a situation we can generate and do it already. And I mean, there are other things we are doing already. So normally you cannot see what's going on over the hill. Is there a car coming on your side? Can it be a crash or not? We can see it in a network. And we are using that information already to prevent that potential crash. So I mean, that's something we do already. And of course, we have some testing centers where we are doing that. And here we are testing 5G. 5G very often, or almost always, in combination with 4G. And we think about what can we do with the new elements this technology brings to the market. And I mean, this is, for instance, this super important car industry. And we are testing things like the next one you can see already with Continental. So with Continental, we think about what can we do to have a digital shield for pedestrians, for bikers, for motorbikers, but also for cars. So we connect all the people being on streets, being in a traffic. And why? Because we want to avoid crashes. At the moment, we have 7,100 people dying a year, so a lot. 7,100 traffic accidents. 9 people are dying every day in Germany. That's 9 people too many. So we would like to really work with technology to support, again, people. So it's about services. And I think that especially 5G will be very much about how to make a product to be a service, to connect things. And this is what we are doing also here. We connect people, we connect things, and we are using that opportunity that everything knows where's the other thing. We are using algorithms. How fast are they moving? How can we avoid a crash? I mean, this is the sort of thinking we are doing. We combine it with technology, and then we are trying to bring out some services. And that's something we use different technology. One technology is called V2X, so vehicle to everything. It could be another vehicle, so vehicles are talking to each other. If some vehicle is experiencing there's some problem on the street, it's sending the information to the other vehicle. We all know cars crashing, bumping on each other. With V2X technology, this is not possible anymore. So it's really, you can totally 100% avoid that crash. Why? Because these cars are talking to each other. At the moment, we have already like 18 million cars connected, and we are now moving into the next phase, next stage of services. And I think a very interesting one, and all the opportunities which are arising out of that technology development. Digital Atlas. Also here we are cooperating already with HERE to generate the best 4G, 5G atlas and collecting information about where is the next parking space, collecting information about is there anything going on in the street, is there any deviation, is there anything you should know to have better commuting, to have better mobility service. And so therefore this movement from the product car into mobility services will be supported by many, many technology elements. But I also believe that it will be a big change. And in the future, you might use for autonomous driving some, maybe 1 or 2 apps, call the car, call the mobility service, and then you drive from A to B. And in between, you will be supported by all these technologies. So I think the strongest is always if you have a clear vision about what you could achieve with technology. And this vision is, at the end of the day, it's traffic without any traffic jam, without any crashes, and think about the crossing without any lights. So you don't have to stop, you just move. And the car is automatically steered in the right speed. The car is automatically moving in a way so that it's not crashing with other, be it pedestrians, be it other cars. So I mean, that vision is bringing CO2 down, so emissions are going down, and overall, people are not dying in the traffic. And therefore, I think it's worth following that vision, and we could do a lot in really hitting that target. And for us, it is not just tech connectivity, but we go beyond connectivity and try to really help people and do something good to people. And the area, the test field we have, it's Altenhofen, which is close to Düsseldorf. And here we have 5G already. So many talk about 5G. Some knowing about 5G, some not knowing. I mean, the discussion we have, and we also heard it today, about the 5G auction, yeah, it doesn't make us happy, but we need to find a way forward. I believe in Europe, we need to build the best infrastructure to make these products become services, and we have many of them. Germany as expert world champion, all that products, make them services, connect them. And here we're testing, for instance, in that automobile area, a few things. One is 5G. 5G with a latency of a few milliseconds. So that will be the big change. You have in 4G, you have 40, 60, whatever milliseconds. In 5G, you can have 1 millisecond, which is really real time. So reacting immediately. So if you pull the brake, it makes a difference if it takes 100 milliseconds or 1 millisecond if there's a wall in front. And so therefore, I mean, that's what we're working on. 5G is there already. We are also using V2X, so we connect cars, and if there's somebody jumping on the street, the car stops immediately. So they are connected. Now, this is the kind of things we're doing. We are also also using information. So for instance, we pull in some information about the weather, about snow, about rain, and then it's automatically influencing, interfering with the car and slowing down. And you also have a look, does the tire still have traction at these weather conditions to make it safer? So I mean, this is the kind of things we are working on. Sounds like far away from a mobile operator, but that's where we're in already. And this is working. So I mean, could be looked up, and this is what we're doing already. Talking about 5G, of course it's the next generation of mobile telecommunication, but it's a fascinating one. It's a few things which are really great, and I think that's important to understand. If this clicker is not 5G, it's not working. The main benefit, if the time is over, then the clicker is not working. That's how it works. So the main benefit of 5G is really connecting things. So not only people, a smartphone will be faster, better latency, but it's also connecting things. There are some expectations that 500 billion of things will be connected to 5G and with 5G. And therefore, all these opportunities which are arising out of that connectivity. So this is what we are looking at the moment. And we believe that we need to be bolder in Europe, bolder in Germany. What we started already, I do remember 3 years ago, we had a discussion that 50 megabit is enough. Nobody says that anymore. That's over, that's gone. I think also due to Vodafone pushing for a gigabit society, and gigabit not just meaning speed, but talking about an optimistic society, about a humanistic society, which means technology supporting people. And this is what we try to do. This is what we try to initiate. And so on the one hand, we are now investing, and this year we'll reach 1 million households connect with our cable, and we're reaching 1 gigabit. It then will move to 10 gigabit, to 25 gigabit. So we connect all our cable customers, and hopefully with Unity, we'll have many more. Then we'll have 25 million households being connected with a gigabit. And just imagine, a few years ago we discussed 50 megabit. This is enough. Germany doesn't need more. Nobody needs it. That's over. And it needs to be over. If we want to have a future, we need to have better bandwidth. We need to have better infrastructure. And therefore, this is what we are pushing. And on the mobile side, I agree. We need to do better, be it in Mecklenburg-Vorpommern, be it anywhere. This connection should not happen. We should fill the white spots. We should do more in that respect, and we know that. And we'll have 4,000 construction processes going on this year, 2019, so a lot. So we invest a lot, we do a lot, and we prepare for 5G, which then will enter and give us some new fascinating opportunities. And we want to be a leader, a pacemaker as Vodafone, really bring together different worlds. I talked about IoT. Vodafone is a world market leader in that one, and of course use all these positive elements of 5G. Thank you very much. Thank you.
Thank you very much, Hannes. Well, let's build on that point about a better infrastructure position for the future and the sorts of structures that are going to enable the possibilities that we've already heard about. Please welcome Professor Anja Feldman from the Max Planck Institute for Informatics in Saarbrücken.
I can just say the same as all my previous speakers. I'm very happy to be here and to be able to talk about the chances and possibility that digitalization will give to us. Digitalization, it's a great opportunity, because what will it mean? It will mean that we can have digital twins of all the elements and the things that we have in the physical world. But of course, in order to enable that, we need a communication infrastructure to be able to kind of update it, to control it, to have the whole processes of actually enabling IoT, optimization, digitalization, those robots that we heard about, the flights, to be able to do all of that kind of a nice technology moving forward. But to do that, we need an infrastructure. And one of the essential infrastructure is not only the 5G network, but the internet as a whole, the network of networks. Just imagine if the internet would fail, oops, what happens? Can we actually reboot it? If we don't have the internet communication, we probably don't have power. If we don't have power, we don't have internet. Those kinds of systems are critical systems that have been highly interconnected. We need to understand how one failure in one system actually affects the other and the other way around. We need to make these systems so reliable that they actually work moving forward as well as in the past. Now, moving forward, we also have new challenges. There are all these communication devices that are going on the network. They will produce billions and billions of data flows. That data, that's the future. We need to analyze it. But let's think about it. There's a simple temperature sensor somewhere. We want to get that information, but not just we, somebody else too. We need to make sure that that data is being delivered to all the people that actually want it, to all the companies, because otherwise we can't have the control functions at all the different granularities. Controlling things at a millisecond, let's say within an airplane, but also then for the planning, to basically avoid the traffic jams. We need to have more central planning information, be predictive. That means that we need to be able to take these data flows, do communication on them, to aggregate, to minimize the data. That needs to happen locally. Then that data has to be communicated further to the different companies. So in some sense, we need a data overlay on top of the internet to basically distribute the data to all the different participants. This is something that we need to build, that we need to establish. And we cannot be afraid. In some sense, if I really want to keep my data safe, I should put it in a safe and put that safe underground and actually forget where it is. Then the data may be safe for some time. But that doesn't really help, because it doesn't solve the problem of accessibility. We need to be able to process this data in a scalable manner and then be able to trace back to, oh, what was the data that actually influenced the result, so that we can have debuggability. That means that we have a lot of opportunities in terms of moving forward with what kind of information process we have to do. Don't be afraid. Let's not actually worry about all the things that we have to deal with. Let's actually do it. And then worry about, this might be going too far. We probably don't want to do that, but we may want to do this. Let's take a look at the medicine and the insurance business. In some sense, for medical information, we do need data, not only about the ill people, but also the healthy people. But from an insurance point of view, it doesn't mean that the people that have a problem should not get insurance coverage. That is something we have to deal with on a regular method. We can't just do that on a technical level. We as society have to agree what is feasible, what is not feasible. That doesn't mean we should never look at medical data, rather the opposite. We should learn from it. We as a society should take advantage of it. So that means that we have to be able to actually go ahead, take advantage of the data, be able to kind of feed into it, but also respect privacy and make sure that we have usable security. Which very much means that from a researcher's perspective, we have a huge opportunity here in terms of doing research, but not just that, we also have tons of opportunities in terms of moving forward on the economic side of things. And with that, I want to close here.
Thank you. Thank you so much, Professor. Before I turn to our earlier two speakers, I wonder if I could just get your sense of where we stand at the moment. As you said, it's not just about 5G and mobile broadband of the future, but also about just the internet. Do you think that right now we have the infrastructure that could cope with the volumes of data that will be transferred in the future and the connected devices and all the advances we've been talking about?
No, I don't think we have the infrastructure. We certainly need more investment into the infrastructure to actually move forward. Because at the moment, if there is a new application coming in that, let's say, doubles the data volume, the network isn't built for that. Now, how can we do that moving forward? We need to have a way to actually finance that investment. And if there's a new application that really introduces a huge amount of data, there's probably some way that that part has to also pay for the infrastructure investment, or we have to make it a public infrastructure. How can we do some of these things? Well, with virtualization moving forward, we can actually virtualize the network and also put computing elements at the edge so that we can have combined computing and communication infrastructure to tackle the needs of the future. For example, enable different protocols that are specialized for video, that are specialized for data aggregation, specialized for other kinds of things.
But that is not a private sector enterprise. That would require government and ideally at a European level.
It could be public sector and regulations, but it could also be via companies. Because in some sense, if you offer a new service, the customer is probably paying for the service. And then that company could actually buy services from the infrastructure providers, which could be implemented on top of the other kinds of networks. Now, at that point, we have to be careful though. We need a public internet, and I think the public internet will stay. Yeah. Because there are many, many different services that are highly valuable, but that don't increase the amount of traffic that much.
So I think you're saying that ideally you would do it through both the public and the private, that it should be a joined up enterprise. Okay, let me then go back to you, Sami, and what you were saying about intelligent robots and that next generation. I mean, are you imagining that in our homes we would have the sort of robot which could do many different things, you know, whether it's a health application or whether it's caring or whether it's basic mobility and household tasks?
Well, I mean, I think this is a goal that will become reality in a certain amount of time that is maybe a bit beyond 5 years, I would say, if we go to the question of having a robot that is really being able to do all kinds of things that we would wish for. So I think what we will see on the road to that, and it's highly correlated with the infrastructure that will come in place, so it's a co-evolution in some sense, is that we will see more and more robots coming out of the safety cages and really becoming the smartest embodiments of the internet of the future in some sense, right? So I really think that what's coming now, and I think, Anna, you just said small, medium enterprises and so on and so forth. So they really will benefit from these new tools that we see that complement workers and really are kind of the stone wedge of tomorrow, right? Or the hammer of tomorrow in some sense. And the more data, the more intelligence we will give them, and the more they experience how to collaborate and to interact safely with humans in our everyday environment, the more complex and the more capable these systems will become, not necessarily autonomously or automatically by evolution, but by us learning from how to build better systems. And this kind of benefits largely from the hopeful improvement in the networks and the data that is available, so that we can actually deal with all that data that, I mean, Tom Enders was kind of pinpointing towards that. Just think about the data that is produced a day in an airplane. Just think about the data that is produced in the most autonomous robot that you can think of, that will be orders of magnitude more. And how can we really go that path without having a step response in some sense? So this is a path, and then just to finalize that idea, I think the more we go into small, medium enterprises, the more we have first help in healthcare applications, the more people will accept and understand that these systems are a help on every day. And
rather
this is
than
also
see them
the
as a
thing
threat, you mean? You immediately then start to perceive this as being valuable.
Yeah, it's about trustworthiness. So this trustworthiness really has to be built up, and people, especially in Europe, have to see, we saw this in the beginning, right, with the acceptance questions that we have in Europe, that we need to really bridge the gap here and make people aware of what is it they want to do and what is the future they could live in. Right?
One of the most interesting things I think you said, if I understood you correctly, that there is a process by which the robot doesn't have to necessarily try for itself to do a task like turning a key, that by watching or by data transfer, it could do that first time without the failure, the stages of failure.
Absolutely. I mean, this is something we're actually showing in the main hall, where we show that a collective of robots, there's one robot that we have here, but the other ones are connected via 4G in Munich, is 20 systems, and they actually act as a collective not parallel, but a collective. And therefore, you can really see how within a few trials, because this collective experiences so many things at the same time, it can basically learn what this child was able to do after many years within just a glimpse of 10 seconds or something. And this is really, I believe, one of the tremendous kind of enablers that we will see if we talk about connected machines. It's about sharing knowledge, it's about sharing the data between the machines, and therefore being a better service to humans. And this will be a large enabler.
So Hannes, I mean, how much might we be held back in really achieving the potential of the kinds of things that Sami is working on and so many other kinds of devices and the Internet of Things, etc., by the fact that our infrastructure is not yet at the level it should be?
I think it clearly needs a very good and working ecosystem. If the ecosystem is not right, so and we need, and it was mentioned before by Nick and also by Chancellor Merkel, we need to have the education, we need to have the software skills, we also need to have the capital, the money to be invested into ideas and also companies, and we need the infrastructure. If we come to the infrastructure, and that of course is a super important thing to us, and it's always the basement for further development. You need the infrastructure, the 5G infrastructure of very low latency infrastructure to make them quick and precise, the robots. And what do we need to do? I think it needs, and it was stated at the very beginning, a together. I'm missing the together. At the moment, I receive information out of newspaper, what we should do and invest. And it's constantly changing. This is not the environment for good investment. We need to be aware that we need to have a great and the best infrastructure. And that means that we need to have stability around investments, that it needs to be a framework which is investment friendly. If it's not investment friendly, and you know, we are having discussions about others should participate without investment. This is not investment friendly. So discussing national roaming, I mean, in Germany you have the saying, Geld schießt keine Tore. In this sense, it's also national roaming is not healing any white spot, and therefore a good understanding. You need to be aware that the companies investing, and there are only a few, need to have a framework so that it really makes fun to invest, and that you are achieving a high or decent return. At the moment, the players in the German market not owning the network have the highest return. This is not sustainable. So we need to change a system and then come to a common understanding, what do we need for the country to have the best infrastructure for robots, to have the best infrastructure for cars, to have the best infrastructure for academic reasons. So therefore, we need it together, and we need a clear plan, and we need to accept certain things. And if we ignore that, it's just a matter of time and it fails again, and we are not moving forward. And we also need harmonization in Europe. So I believe, I mean, this fragmentation, it leads nowhere.
And we'll be speaking to Commissioner Oettinger from the European Commission after lunch, so perhaps that point about harmonization is one I can ask him. Anja, I wonder where you feel we are now in terms of awareness, you know, because obviously you are very knowledgeable in this area, and all of you are, and you see not only the potential, but what is going to potentially move against it. Do you feel you are getting through and that people understand that we are going to really need to think about the building blocks as well as the technological advances?
Okay, one of the things that we've learned with the internet is there is no other constant than change. And change is one of the things that is always happening. And I think we need to be able to be much more aware of the fact that things will be changing, to accept that. And this was talked about earlier today when we talked about, oh, people just want to come into a company for 2-3 years for an interesting project, move on. Yes, that is true. People want to have fun. They want to kind of be challenged. At the same time, we have a lot of people that say, oh, but I want to stick to what I've learned. I'm not willing to change. That doesn't work. We need to be able to kind of constantly educate ourselves, constantly learn new techniques, constantly adapt to a highly changing nature in order to be able to take advantage of the digital age. Do we have all the building blocks in place for that? I don't think so. Much more is needed. People need to learn what computer science is. They need to be able to distinguish an algorithm from a heuristic, understand what they can do, what they cannot do, be able to kind of see forward. This is not just a school system. This goes into the academic life of the university. It goes beyond that, even for the old elderly. For them to accept the health robots, they have to understand that this is not threatening. We have to be able to move forward on that part of the society as well.
Do you think, though, that in your concept of change, do we need a version of what we have already, or do you believe in the ideal, the vision that's been put forward by Tim Berners-Lee, that maybe we need another internet, a different internet, a decentralized one?
The internet is already decentralized. It's a network of network, and that's the infrastructure. With regards to what we need on top of that, there's a huge question whether we need actually kind of a centralized elements that are there as brokers, or whether we do need this as a decentralized kind of form, like in the whole blockchain discussion. But there the question is also, do some of the current ideas we have scale, or will they be limited in terms of their scalability? And at this point, there are, on the one hand, tons of opportunities where we shouldn't say no, because for some of these elements, we don't need brokers. We can actually decentralize it. We may not need a government involved. And cryptocurrencies are there. They will stay. The current ways in which they are being computed, that doesn't scale because of the energy that is being used. But the principal ideas will stay.
Yeah.
We cannot apply it to everything where people want to do blockchains at this point because of the scalability powers. But it will be there, and decentralization without state, but with some regulations, will probably be there.
We just have a few minutes left of time, so I want to come back to both Sami and to Hannes before we close this session. Sami, it's clear from the tech divide study that there's a lot of, and it varies, but people have a worry, for example, about being controlled by robots in the future. Given your work, what is the best way to think about that age of intelligent or even more intelligent robotics?
Well, I think what we really have to take very serious is that people are kind of worried about the pace that technology is taking over the last decade or so, and they would like to be part of a process in understanding better what this is about, what is it we are doing there. And I think this has to kind of be mirrored in the science and technology development, in the sense that we think much more about what is it that we do that helps people and that really makes technology accessible to them. So in some sense, if you think about the internet as being the democratization of information and knowledge, then the next generation of the internet, including robotics and AI being part of that, is, I guess, about the democratization of skills, right? Making humans be able to travel instantaneously across the globe, bridging the gap between kind of or making skills available on other sites, remote sites instantaneously and things like that. So people have to understand why should they be part of such a society. And I think what we also need to do in some sense is really take education much more serious and really on a broad scale, meaning not only to train and educate the workforces of today to be kind of also be able to use this new technology tomorrow, but really going into the schools, going into the high schools, really kind of educating our children to be able to be trustworthy engineers, right? So kind of an initiative we're doing in Munich is now really, and together with the leading technical universities in Europe, is can we kind of educate the European engineers, meaning engineers that do not only develop products and understand how to do the best products, but how do these products affect our lives? And I think this has to be really inside the way that we kind of want to develop and understand technology. And I think this is a process that has to be really kind of taken serious in a way.
And Hannes, in your work, what is the most common misconception that you come up against when it comes to the key technologies of the future, whether it's 5G or others, and that you feel you really have to fight to combat?
I mean, the discussions are always very emotional, which is good and bad. On the one hand, everybody's using the service. On the other hand, if there's some frustration, it's always then a loud frustration and it's being articulated. I mean, I think what is really missing is to have an ambitious infrastructure plan for Europe to harmonize. And I was really annoyed when I started here at Vodafone 3.5 years ago, and the discussion was 50 megabit is enough. And there were kind of singing and please sleep and don't discuss and 50 megabit is enough. And we said, no, it's not enough. If you look into the future, everything what might sound comfortable for the moment is normally not enough for the future. And therefore be more ambitious. And there was no plan, there was no ambition. And if you believe that infrastructure, capital and education, these are the three vital elements which are super important for having prosperity in the future. And if you believe in that, you need to invest in it. And the return will be immediate, or maybe growing and building up. But that's for me, to have a more long-term thinking. We are always like the next day, the next week, this year. Infrastructure, the same with education. Money might be a bit faster, but that's long-term thinking. We need to build every day. And if you're not doing that, and if you don't have that concept in our mind, we would fail on that one. And we are failing here on certain points, and that's not good. Not good for Germany, not good for Europe.
It is a sobering thought. Thank you all. Ladies and gentlemen, I just want to give you a couple of words about some practicalities before we break for lunch. One is that please do take the opportunity to have a look at the technology showcases. Also, straight after lunch, we're going to have a live video call with Günther Oettinger from Brussels. He hoped to be here, but unfortunately he couldn't make it to Berlin. So we're going to have a live call with him, and that is going to start at 1:45. So please, if you could be back in this room at 1:40, you'll hear the gong, so please come back in straight away. And finally, please join me in thanking Sami Haddadi and Hannes Amtsreiter and Anja Feldman. Thank you.